Our speaker today is Jason Anderson. Coincidentally, he's also this group's new organizer. I had messaged on Monday to the entire group that I was stepping down. And when I was mentioning this to Jason 2 weeks ago, he asked me whether I asked him whether he would like to step up, and he enthusiastically agreed, so which is great. Jason's detailed profile is on the meetup page, but a few quick words. He's a cognitive architect and partner with Comp3, and he has Comp3 is a consultancy which is based in San Jose. Prior to Comp3, he was with IBM Cloud Labs for 5 years as a cloud architect. He was also an IBM Master inventor and has been associated with more than 30 patents. He's a computer scientist educated at Cal Poly. A list of his published papers are available on the meetup page. Personally, I'm very happy that he has stepped up and become the new organizer. Over the last few months, we've also become good friends. And I wish Jason and Sophie, the assistant organizer, and all of the group, all the best.
Thank you. I want to say thank you to Ashish for doing such a great job communicating and building this meetup group. And now hopefully I can carry it on with the same fervor and passion that he has. Great. So today though, I'm going to be talking about IBM Watson and adding it to your applications. And so you already gave my beautiful bio, so I can skip that. And just a disclaimer at the beginning, I don't technically work for IBM. Like you mentioned, I work for a small consulting company focusing on cognitive computing. But I do consult with IBM. Can you guys hear me okay without the mic? Or
Mic is better.
Mic is better? Alrighty, how about this? Good? Awesome. So today I'm going to talk to you guys about, we'll give you a history, an overview of Watson technologies, how they started with Jeopardy and how they've now morphed into more componentized architecture where you can grab the capabilities that you need as a developer and package those together. Then go specifically into the Watson Developer Cloud, which exposes those capabilities. And then take a particular service, the natural language classifier, which you give it a string and it classifies it into one of however many categories you provided. You can build your own, so that's the one service we're going to go into. And then finally talk about which apps are best suited to work with Watson. So you have a lot of data being one of those types of things you'd need to work with Watson. Cool. All right, so most of you in the room probably know IBM started Watson a while back with the intent of a machine that would play Jeopardy. And so the result is IBM Watson was able to beat some of the world-leading Jeopardy players successfully and without much error in the question answering that they were giving. So that was the start of it, and behind that was a lot of NLP systems. So how do I, Watson, understand these answers that they're giving me to come up with the correct question to get the points. And so that behind it, at NLP, I have to understand the question. I have to have a large corpus of data which to go into and find the relationships, find what the answer is getting at. And so these technologies, while really great at playing Watson, nobody wants to buy a Jeopardy playing machine. So IBM can't go to their clients and say, all right, you want to buy this Jeopardy playing machine, but it doesn't really solve your business problem. So what they had to do is take these technologies, break them down into components that could solve business problems, and then repackage that into their offerings. And so that's what they've basically done. So they have a couple of kind of larger prepackaged offerings, which I'll briefly talk about, but then they've also exposed their capabilities into these microservices, and that's where I'll focus today. Because as developers, you're going to be working with these microservices and not necessarily with the bigger offerings. So I'm going to name 3 up here. Like I said, I'll briefly go over them. But the first offering for Watson is the Engagement Advisor. So this is a prepackaged solution that takes in questions, and let's say you're running a service test and you want to automate the service test. So this is a product where you can feed in a history of transcripts, how a representative answers them, to create a solution that then can be sold to one of their clients. So that's the Watson Engagement Advisor. Next up we have the Watson Explorer. And this really pulls from multiple different data sources, so they have connectors, and it pulls it all into one single place where it's indexed and able to be searched and compared against. That's Watson Explorer. And then the last offering is the Discovery Advisor. This is really more directed at a particular domain. Let's say I'm an ontologist researcher and I'm looking for a particular gene that expresses in a certain way depending on if this cancer is present or not present. And so this tool, the Watson Discovery Advisor, really helps researchers do that more quickly and define relationships that maybe would have taken them a lot longer had they not had this tool. All right, and the one we care about today is the Developer Cloud. So the first three were prepackaged offerings, but Watson Developer Cloud is really specific and breaks into the, let's say I need speech to text or I need text to speech. Let's say I need something where I can give it a picture and it'll tell me back what's in that picture. And so these individual capabilities is what creates this Watson Developer Cloud. So here you can see the list of services that they have today. There are 18 up on the screen. So here you can see there's the text-to-speech and speech-to-text that I was mentioning. If you want to do translation within your application, they have a language translation service. So these are all API-based. You just give it your information. Watson does some number crunching, string manipulation, all that good stuff on the back end, and you get back your answer out of the service. And so the one today that we're going to be looking at specifically is this natural language classifier here. So in order to get access to these services, it used to be most of IBM's technologies would be installed on-prem. It would take a while to install them, but really IBM has switched to a, you could say, like cloud-first model, where things are made available via the cloud, and that makes it really easy for developers to get access to them. They don't have to sit there and install on their laptops or get a server provision. They can just access an API and have that service available. So Bluemix is their platform as a service offering. This is actually one of the products that I worked on when I was working in their cloud group. And so the basic idea with Bluemix is I have code that I've written. I know what services I need. I need a database. I need a message bus. And you basically tell that in a template, and you send it to the cloud, and it deploys it. And so that's the idea with Bluemix. So today, the best way to get access to these Watson services is through Bluemix. I'll show you how to do that. So the example class, or the example service we'll be using is the natural language classifier. So maybe a show of hands, who here knows what a classifier is? All right, pretty good distribution. Basically what a classifier is let's say I have a problem where I have a certain set of items, and I want to tell if they're in one group or another group. Let's say I want to tell if a picture is a cat picture or not a cat picture, for instance. And what a classifier does is it's technically a type of supervised learning where you give it a bunch of pictures of cats and you give it a bunch of pictures that don't have cats in them. And then based on that information, it can train itself to then take an image that's never seen before and put it in one of those categories. And so that's basically what the natural language classifier service will do. It will put things into categories that you've defined. So a little more specifics about the service itself. The topology that it's using is a convolution neural net that's fixed and defined by IBM in their backend service. There are some extra components there that they've implemented, so it's not just a convolution neural net, but that's what it is at the crux. And so this is already predefined, and as you give it data, the training data, you're going to find, let's say you gave the classifier the same set of data 3 or 4 times. You'll find that the results basically won't be identical, but they'll be very similar. That's due to the statistical nature of the training process as you're training that convolution neural net. Let me pause here just to say everybody on track with what a classifier is and all that good stuff. Cool. All right, so now the fun part. So I've been using a to-do app called any.do for the past year or two. And basically every time I think of something I have to do, I open up the app on my phone or on my web page, and I type in the to-do so I don't forget about it. And so I've been doing this for a while now, and I have about 1,000 to-dos. And so I thought, hey, what a great data set where I can actually do some cool stuff with it. So that's the example that we're going to be using tonight. So I've taken this data set, I've classified them in 2 ways. The first way is by type. So I've taken my to-dos and said, is this personal or is this work related? So that's the first type of classifier that I'm going to implement. And then the second one is based on importance. And so this is going to be a low importance, a medium importance, or a high importance. And so this is not a binary classifier, but there's 3 classes, but you can basically use the service the exact same way. So for creating, basically the first thing you need to do is create the NLC service. So doing this, you get your data. And so I have some sample data here. So if any of you want to try this out after the meetup, feel free to. I put everything, all my code on GitHub. And I also put the data here. So if we click on this link, that's not right. Here we go. We can see here's the work versus personal data set here. So here's a list of to-dos on the left-hand side, and then whether or not they're work or personal related. Similarly, for the importance classifier, here's the list of the same to-dos, and then whether or not they're low, medium, or high importance. So these are the 2 training data sets that we're going to be using for a classifier. So the next step is to actually create the instance using Bluemix. So now what I'm going to do is go to Bluemix, log in. So with Bluemix, there's a free trial for, I believe it's 30 days, so you can use any of the services that you want, deploy applications. And then from there on out is a free tier. So you can do a lot of stuff with the free tier. That's what I usually use. Got like my website running off there and some other stuff. So it's really easy to sign up and get started with it. So if you look here, I have the Cognitive Meetup app already deployed. I'm going to show you the steps to get here. So we'll go first to the catalog where we can create our NLC service. Bluemix has a lot of other things available. But what we care about here are the Watson services. So you saw this in a previous screenshot. We're now going to go to the natural language classifier. Here's documentation if you wanted to go and see what limitations are there, how you want to set up your training set, all that's notified here. Give your service a name and then click create. So what it's doing now is Bluemix is going out and not creating an actual neural net. That's what powers the classifier. We have to give it the training data before it can train the neural net. But what it's doing is setting up our credentials and getting access to the service that we can use. So now that that's done, we can click on the service credentials, because we're basically going to use the curl command and the credentials we have here to provide it the data to create our classifier. So we'll take our username and password. And so this README with the curl commands is part of the sample application that I've provided. So you can feel free to go and grab that. So I'm going to go ahead and replace these values. So here's the curl command to actually train the classifier. So we have our username and password. We'll have to provide that with every API call we make. And then we need our training set. So here we can provide the curl, our training set file. So if you download the application again from GitHub, you can go into the sample data. You can see there's 2 here. Here's the type, sample data.csv, and then here's the importance one. So we'll run our curl command from the sample data directory so we can find our sample data. We'll paste that here. And then lastly, we need to name this classifier. So this is type, whether it's personal or business, so we'll call it the type classifier. So now we have a curl command to start training our neural net. So I'll copy this, run it from within our sample directory data. And so basically, you get back a JSON response saying that your classifier instance is in its training phase and it's not yet ready to accept classification requests. So this process, depending on how much sample data you have, can take up to 30 minutes, say if you give it a lot of data. So while you're waiting for this, what you can do is get the classifier's ID. So there's another API call. Actually, you don't even need to do that. It's right here. So you can take this classifier ID because when you actually want to use the classifier, it's the classifier ID that you're going to be accessing it with.
Can I ask you a question?
Yeah.
So if you add a little bit more data to your training set, do you have to start all over again, or is there a way to incrementally add that to something that's already been trained?
So right now,
Sorry, just could you repeat the question?
yeah, so the question is whether or not if you already trained your classifier, and let's say you have 10 more samples you want to add, if you have to rerun the whole classification process to update your classifier. And so the answer to that currently is yes. I believe they're working on a way so that you can do the incremental updates. Because if we have an application and we allow people to classify something, and if it's wrong, and they can check that, that's a great way to help our application basically get a feedback loop and start building a better and better classifier. So yeah, so that I think is coming, but I'm not 100% positive. All right. So we can check the status of this using the ID and another API command. So here's an API command to check the classifier status. Place the ID here. Grab our credentials. Easier to do this two-handed. All right, so now that we have a command, we're going to go ahead and run the curl command. And you can see here it's still training. So you would continually run this command until you actually, it says classifier is ready to accept classification requests. And so like I said, that can take up to 30 minutes. So you just check back occasionally. But once the classifier is trained, your application can continue to use it. So we're going to do the cooking show thing and switch to a classifier that I've already done. And so the classifier command to actually run a classification request is here. So you basically specify your classifier ID and then the text you want to classify. So here's mow the lawn. So I want to figure out, is mowing the lawn work or personal? So I'll go ahead, run this command. And then here's the JSON you get back. So it says the text that you want to classify, tells you what the top class is, and then it gives you a confidence of what the classifier thinks is personal and how likely it thinks it's work. And so here, it's pretty resounding that it's a personal task. And so that's what I would report through my application. So this is great. So we're able to create a classifier, use it to classify data. But nobody really wants to run curl commands in their terminal window. Everybody wants a nice shiny app where you can access and look at things. So now the next step is to actually build an app that uses these APIs and uses this trained classifier. So it'll give it its likelihood of which one these are. Or do you mean in a to-do list?
Well, you got 1,000. So suppose you want the top 20, let's say, with the highest priority.
So with you could code your application to give it the top priorities and have those come up. But the idea is that was our training set. So what we care more about is what the future is. So that's like the history going into the classifier.
Yeah.
And then for new ones, we'd be able to automatically generate a classification to it. So you can see this classifier being used potentially to integrate with a service like any.do, so that it can automatically tag and promote the things that it thinks are high importance, or put them in the right category, add the right type to that task, if that was something you were tracking. And then you could obviously correct and do feedback, depending on the accuracy of the classifier. All right. So here are some tips, and part of the reason why a lot of things in my current app get classified as low importance. But basically, data coverage is one. If you have 10 training samples and that's all you have, your classifier doesn't have much to go on. So don't be surprised if you give 10 data points and it does a terrible job classifying things. You want to make sure hundreds, thousands are obviously better, depending on how much data you can generate and tag. And then the other point, you want to make sure you have a relatively even spread with the categories. So low importance in my case is over 50% of my tasks are classified as low importance. So there's an inherent bias for the classifier to kind of weight things of either, I don't know, it's going to be jammed in this low importance category, or it's made a bigger circle. If you look at these classifier lines, it's made a bigger section of low importance, so more things by default will get classified there. So you want to try to make sure you have a good, even spread of your sample data. The next thing is accuracy. If you're hand annotating and hand tagging your data for classification, hopefully you do a good job, and that accuracy then will translate to the classifier that's built. If you have a few misclassified things, let's say you're dynamically generating this data set and there's some issues with some inaccuracy in your training data, that will then propagate into the classifier that's trained. So you want to make sure that your accuracy is as high as possible in your training set. And lastly, the feedback loop idea. Kind of touched on this, but the idea is if you have an application where you can ask for feedback from your users, you can then take that basically correction, feed that back into your system, and because of the way that these algorithms are implemented, it can make use of that and just get inherently better. So over time, if you can create some kind of a feedback loop, that'll be much better for your system as a whole. And so there's some additional NLC specific tips you can find in the documentation. So I just put a link here. All right, last up is what apps are good to start thinking about. Watson might be a good fit for me. Yep.
So as far as a hierarchy goes, if we use a parent-child relationship, does each child have to have their own, how many children can be supported?
You mean like if your data was relational?
Right.
So the question is whether if you have relational data, you can use it, or how do you apply it to something like the natural language classifier, is that correct?
Well, I'm just thinking if you had like each one of your highs then had another category to it. And so how would you then, you have to have separate data sets? Would you have to understand the bottom before you move up to the top?
So I think if you have multiple categories, you can do two things. So if you look at the sample data set that I have, so there's two approaches. If you have two distinct classifiers, like this is of high importance and it's work, you then could build a classifier for each thing that you're categorizing for. So I have the exact same tasks here with the importance data set, like add fav icon to website is low, and this is training set for the importance classifier. And then in the type classifier in its sample data set, I have add fav icon to website, and that's work. So you can create a classifier per thing you're classifying into.
So is there two classifiers there, or just one?
There's two classifiers, yeah. So the idea is you'd have an IDA, you train each classifier separately, then you can make as many classifiers as you want available to your application, and they can make separate requests for each classifier that they need. So yeah.
So is there any limit to how many classifiers can be inside?
I don't think the service has a limit for an account of how many classifiers you can create. So they're basically their own neural networks that you're going to create and train that then you can make a request for classification. The other thing, and this is tangentially related, but let's say you have a category, or let's say you have an item here that belongs in multiple categories. It doesn't make sense with what we have here because our categories are mutually exclusive. But let's say we have a classification like computer related or work related or personal, or well, let's leave personal and work. Let's say like computers, networking, kitchen. You can actually in your data set put multiple categories that this particular data point belongs to. So you can add to your data that way. It's a little cleaner with the classifications that are mutually exclusive because everything belongs to one particular. But you can have, if something isn't mutually exclusive, you can add multiple tags, multiple categories to a particular data point. Okay.
Is it also possible to classify a whole document, like email or Word document and PDF?
So the question is, how could you classify an entire PDF? And so, what would you classify, or what would you want to do with it?
I need to organize thousands of documents in certain folders, but instead of creating folders, it is going to be variables.
Yeah. So what I'd probably do is take a sampling, maybe the first paragraph of the document, because you can pass in any string to be classified. So instead of sending in, I don't know, an 18 megabyte text file or something like a book or something, you want to classify a book into a category, I would probably take a subset, like the first paragraph or something, and send that to the text classifier and see what kind of results you get. Maybe it works well, maybe it doesn't. And if it doesn't, then try to iterate, maybe pull words from different parts of the document to get a classification. But I wouldn't think sending all of the text would be, first of all, you'd probably overload the classifier, and then also you wouldn't necessarily get much better accuracy than just a subset that was representative of that document. All right, so Watson applicable apps. So here are a couple points. If you're thinking about using Watson, if you meet any of these categories, then it's probably a good idea to take a look at the Watson services and see what might be able to be integrated. So the first one is having lots of data. Lots of Watson services like the NLC classifier, if you start looking at the training and the rank and retrieve, need a lot of data to work properly. So the more data you can give it, the better the service is going to be for you. So if you have access to the data, then that's great. If you have to hand annotate tasks like I did, still not awesome, but you can spend an hour or so going through and doing that. But if you already have the data, that's awesome. The second thing to note is if you have to communicate natively to humans, let's say speech to text, text to speech, if you have to work with different languages, something like the language translation service might be extremely helpful, so that making a computer, that human computer interface more natural, that's something Watson does fairly well at. And then lastly, anything with a lot of domain expertise. So if we look at health, or we look at law, or something that has a lot of jargon associated with it, the way that Watson works and the indexing and the machine learning methods that it uses does really well on those types of problem sets. So anything with a large domain that's fairly vast, that's another good option for a Watson application. The last thing I wanted to mention is a lot of people have been wanting to build their own question and answer system. So I want to be able to ask something questions, an agent or chatbot or something like that, or I want to have a service where people can go in and get help for something. There's three services that work extremely well together. And so this is really the decomposition of what made Jeopardy work and what makes the Watson engagement advisor work well, are these three here. So you have dialogue, and what dialogue does is it basically directs a conversation. So let's say I ask you how your day is. Is it good or bad? It's like, oh, if it's bad, maybe I should follow up with what's bad about it. So this kind of branching tree structure is what dialogue provides. I think the sample application they have up there is ordering a pizza. So it basically asks, how big of a pizza do you want? Large, medium, or small? And it says, what kind of ingredients do you want? And then it basically goes through this whole dialogue tree. So that's pretty cool. So that's what the dialogue service provides. The next is the natural language classifier. And you need to take these human responses that are coming in and try to classify them into something that you're expecting. Like, is this response a valid response to the size of a pizza? Or is this response valid to an ingredient list that I need to then put through to the request for the pizza to be made? So the natural language classifier does a good job of that. And because it provides associated confidence levels, if for some reason you're not fairly confident versus that method, classifying what the user wants, you can then go to the rank and retrieve service, which uses more of an index-based querying. I believe it's Solar underneath the covers for the retrieval. And then it does a ranking to figure out which one of these responses is the best one given to what the human user is talking about. So these three together, if you're trying to build a question and answer system, these three are a nice design pattern to start looking at. Yeah.
An example of that third one?
Yeah, let's say you have, so an example of a rank and retrieve. So let's say you have a frequently asked questions that you have on your website, and you want to be able to help people like reset their password, or you want to help people figure out how to do a certain thing within your site. You could load an FAQ into the rank and retrieve service, and then based on what the users are typing in, it will then go in, find the appropriate section of the FAQ, and then pull that to the top. And then given that it has a high enough level or confidence, you then would display that to the user. Otherwise, you could say, I'm not quite sure what you're asking, give a generic response, and the user can rephrase, and then based on that, you're likely get a different response from rank and retrieve that's suitable, and then you would show that. So FAQs is a good example for that.
Small question. Can this be used for something like actually making the decision? So you gave an example where it just looks up the information. But what if, let's say, it asked the user something and the user replied something, so now it has to make a decision? Not like display help or something, but actually they interpret the answer. Can this be used for it, or is there any other service?
Okay, so the question is, if you have a multi-step kind of question and answer and making decisions based on that, if you need something else, the answer is yes. You would use the dialogue service to orchestrate this whole conversation that you're having. And then each of the individual steps and decisions on what to say back, and then ask for more response. For a different response would be using the natural language classifier in conjunction with the rank and retrieve service.
But that means that you have to design the decisions up front, right? So it's like you expect certain things and you try to match them. What if you have to make some decision like which you couldn't predict, you know?
So
can it be that, let's say, somehow system outputs this decision with the highest rank, so I take it? Can it be used in that way?
So I mean, I think it does what you're saying, where it will pick the highest ranking result, and whether that's a follow-up question or whether that's a definitive answer.
Okay.
That was what would be populated up. Yep. Right. So, kind of in summary, Watson started back as a Jeopardy system, has now evolved to really be a collection of services and components that developers can go in and say, I want this piece, I want language translation, I want natural language classification, and pick and choose and build their apps using these REST APIs. The natural language classifier in particular allows you to take a training set of data that's tagged, feed it into a classifier that then gets trained, and then you can give it new strings to then categorize. And then lastly, Watson is great for any data-heavy applications that need to communicate natively to human beings, and that's really a focus. If you're looking to add Watson to your app, if you fit in those criteria, definitely should take a look at the services.